All right, today our objective, you will be able to solve problems involving the Pythagorean Theorem. Okay, so taking a look at the board, you should see what you already know is the Pythagorean Theorem. A squared plus b squared equals c squared. What do we call the longest side?
Hypotenuse.
The hypotenuse. The other two sides are both legs. A and B are interchangeable. So I could call one A and the other B. I could switch it. It doesn't matter as long as C is the hypotenuse. So take a look at the next one. I want you to go through and I want you to circle the hypotenuse of each triangle. So I'm going to do the first one. I'm going to use my highlighter. So here is the hypotenuse of this triangle. I need 3 more people to come up. So these are all correct. I want you to call them all C. And what are the other two sides?
A or B.
A and B. Doesn't matter which one's which. So give it an A and a B and an A. Doesn't matter. A, B, B, A. I want you to put a square around the hypotenuse. So now we don't have a picture anymore. So you should be able to do it with a picture. You should be able to do it without a picture given the side length. So put a square around the number that you think is the hypotenuse and put a circle around the 2 legs. So I'll do the first one. 5 would be the hypotenuse and 3 and 4 would be the legs. These are all correct. Now that we have them circled and squared, which one's C? The square is C and the others are A and B. So I want you to actually write out the Pythagorean theorem now with the correct numbers. So for example, 1 would be 3 squared plus 4 squared equals 5 squared. So these are all correct. Now the number 1, let's see what this actually comes out to. What is 3 squared? 9. Plus, what is 4 squared?
16.
And that should equal, what is 5 squared? 25.
Oh, that's cool.
What is the left side of the equation come out to? What is 19 plus 16?
25.
Equals,
25.
is that a true statement?
Yes.
Yeah, the Pythagorean theorem worked. The left side equals the right side. Okay? Try that out on 2, 3, and 4 and see if the Pythagorean theorem works for the rest of them. So that one did not work. On number 3, if I put this in my calculator, and I compare the left side to the right side, so if I do 4 squared plus 6.93 squared and hit enter, what do you get for the left side? 64.0249. And then what is 8 squared? That's the other side of the equation. Not exactly 64. It has to be perfect. So when Mr. Starks created these notes, he probably rounded them. I rounded the numbers. So, but the way that this works, or the way that it's up here, this is not a true right triangle. In order to be a right triangle, the Pythagorean theorem has to be perfect. The left side has to exactly equal the right side. Does 4 work?
No.
Is it perfect?
No.
No. So those 3 are not perfect right triangles. They might be like 91 degrees or 89 degrees, but they're not exactly. Okay, the only one that worked was number 1. So we always start out with the Pythagorean theorem as a squared plus b squared equals c squared. And if you can do an addition po, a subtraction po, a multiplication po, or a division po to get to one of those, then that's a valid form of the Pythagorean theorem. It might look different, but it still works. So for example, if I wanted to move b squared to the other side, what would I have to do? Subtract it over, right? Do a subtraction po. So that cancels out. The b's are gone now, right? So what's the only thing on the left side of the equation? A squared. And there was a c squared already over there, but now I have a b squared that's subtracted, right? So is number 1 a valid form of the Pythagorean theorem? Yeah, the b's just subtracted on the other side. That works. That is a good version of the Pythagorean theorem. Okay? Now do 2 and 3. See if those are exactly the same. They're not the same, but they are valid forms of it. They're equivalent. Yeah, so divide. If you do a little division po, divide through everything by 2, what am I back to? A squared plus b squared equals c squared. So that also worked. Okay? Now what about number 3? What needs to happen for this to work? It needs to be added. And nothing changed order. They just randomly changed one of the signs. Can you just change one thing in an equation and ignore the others? No. So this is not a valid form of the Pythagorean theorem. Okay. All right. Now we're actually going to do it. We're going to use a Pythagorean theorem. So, first of all, two things. One thing you have to have. What is the first and foremost thing that has to happen to use this Pythagorean theorem?
Right.
Has to have a right angle, which means it's a right triangle. I would write this on your notes. It has to be a right triangle. And then the second thing, what else do we have to know for it to work?
2 sides.
Yeah, you have to know 2 of the 3 sides so that you can solve for that one missing variable. So you have to know 2 side lengths. So the first thing I like to do is label what's missing. So on the first triangle on the left, am I missing an AB or am I missing a C?
C.
Yeah, so put a C there. And then on the second triangle, am I missing an AB or am I missing a C?
A, B.
Yeah, it's one of the legs, so pick one, A or B, don't care.
B.
I heard A first, so I'll do A. And Tessa said B and I don't listen.
Wow.
Okay, so now let's focus on the left one. Let's set this up. So A squared would be what?
3 squared.
3 squared or 5 squared, it doesn't matter which one's first. 3 squared plus 5 squared equals C squared. You could make it an X if you wanted. I like to keep it as a C to remember that this is the hypotenuse that I'm trying to find. Okay, now the next step, simplify what you know. So what is 3 squared? Plus 5 squared is 25 equals C squared. Now once again, simplify what you know. Obviously we know that 9 plus 25 is 34 equals C squared. What undoes addition?
Subtraction.
What undoes division?
Multiplication.
What undoes a square? Because I don't want to know what C squared is. I want to know what C is. Square root. Good. So we need to square root both sides. We need to square root PO. Sorry for my use of ugly colors. We now have C equals. And now, for now, let's just write this as the square root of 34. The square root cancels out the square, so C is all by itself. But the left side of the equation is now the square root of 34, which is very different than just 34. Just, yeah, we'll get to that. So this is a big difference. Some people forget the square root. They just say 34. Now think about this. If I asked you to go home tonight and run 34 miles, what are you going to say? Right now. But if I ask you to run the square root of 34 miles,
Nothing so.
if it turns on, is that more manageable?
Yeah.
Yeah, about 6 miles. Still a lot for some of us. But it's very different, so make sure you don't miss your square root sign. Okay, now you need to do a little dates to prom. Go ahead and do that. So it doesn't simplify. That is your answer. Now that's a good answer. I want you have to have 2 answers for these, for now. Now sometimes the directions will tell you a certain way, but for good practice, I want 2 answers for now on. I want the simplified square root, and in this case the square root of 34 doesn't break down any further. And I want a decimal. What does this sign mean? Do you know what this sign means? Have you seen it before? Yeah, what do you say? About. Yeah, it's exactly right, or approximately. Anytime we round a decimal, we should use this sign instead of an equal sign. So now, put it in your calculator. The square root of 34 is what?
5.83.
Now, for the sake of notes, I want to bless you. I want to always round to the 100th place. How many decimals is the 100th?
2.
2. So remember, anytime I have a decimal, oh gosh. Oh, that just kept going. So 5. Did you see that? 8, 3, 0. Okay, so what is this one called? 10th. What is this one called? With the TH on the end, right? 100th. And this is the...
Thousands.
Yeah. So, with a TH on the end, thousand. So if I want to round to the hundredth, what do I have to look at? The thousandth, the one after it. And if this is 5 or greater, what do I have to do to this number? Go up 1. So in this case, if I want to stop at the hundredth, I look at the thousandth. What is my answer going to be?
5.5.
Yeah, it's about 5.83. So I want 2 answers for all of these. The simplified square root is what's going to be on the ACT. When you're juniors and seniors and you have to take that ACT to get into college, that's why you need to know that. You need to know how to do dates to prom because that's what it's going to be on a multiple choice test. But in real life, which one makes more sense to you? Go run the square root of 34 miles or go run about 5.8 miles? Which one sounds better? Yeah, that makes more sense to us. So you need to kind of understand the concept of both. Okay, do the next one on your own. Teach, what is 8 squared? 64. Avery, what is 12 squared? Good. Now, just like in Algebra 1, I need to get b squared by itself before I can square root it. So, Kaylee, what do I need to do to the 64?
64. Yep, I did.
Kaylee,
What did you say, Tom?
what do I need to do to the 64? Subtract it over. So the b squared is by itself now. And b squared is equal to what? What does this simplify out to? 80. And once again, we don't want to run 80 miles. We want to run the square root of 80 miles. Very different. That is, 80 is totally wrong. So, b equals the square root of 80. And then we need to dates to prom. You always need to simplify your radicals. It's not even going to say in the directions. You just have to do it. Okay, so we did this one earlier, didn't we?
Yes.
On the other side of your notes.
Yes.
So just for good practice, should come out to 4 squared root of 5. That is the exact answer. But I also want you to come up with a decimal approximation. So now is the point where you put 4 square root of 5 in the calculator. And it's about 8.94, and then we look at the next number, it's a 4, but it's less than 5, so we leave it as it is. So 8.94 is the decimal approximation. That's the same answer, one's just rounded to a decimal. I want you to draw a house. And in that house are John and Lisa. Where does John go?
South.
Yeah, now let's use our compass on a flat piece of paper. North, south, east, west. So if I'm going south, that means he's going straight down. How far? 7 miles. So John is now down here. I'm going to erase him out of the house. Hi, John. Where does Lisa go? East. Lisa goes this way, 9 miles. So now Lisa is over here. It asks, how far apart are John and Lisa? What did we just make?
Right.
Yeah, straight south and straight east would be a right angle. We just made a right triangle. So use the Pythagorean Theorem to find the distance between John and Lisa. C equals the square root of 130. You get that?
Yeah.
And 130 doesn't reduce because we get 13 and 10. 10 is 2 and 5. 13, 2, and 5, there's no dates. So that is our simplified square root. Lexi?
And C is about 11.4. Right?
11.40.
Oh, I wanted to. Oh. Yeah, but the O is not new.
Put the 0 there to show that we did round to the 100th place. That shows that I looked at the 1000th and it's still a 0. Even though it is redundant, it shows me how you round. And let's give it some units, because this is an application problem. How far is it? Yeah, about 11.4 miles. Okay, last one for today.